Hello. So in this video, I'm going to show you how to use Excel to calculate the binomial distribution, right? So we learned the formula for the binomial distribution, which is very complicated, especially when the parameter n is large, a large number, then it's extremely complicated to calculate the combination. So you will need to use a calculator or Excel or any other program. So let's think about this example from the slide. We have 10 reservations and probability of cancellation is 10%. They are independent, and we are interested in the probability of 2 cancellations. So how do we calculate that? Technically, we can apply this formula like this. So first, we are going to, by the way, remember, there are 10 reservations and probability of cancellation is 10%, 0.1. Then first, we can calculate combination. Number of combination, choosing 2 out of 10 is, can be written in this way, 10, 2. So use the formula COMBIN, combination, that when you choose 2 cases out of 10, then there are 45 possible cases. And then the probability is 45 times success, 10% cancellation happens twice, and failure happens the other times, 10 minus 2. Okay? So, what's the problem? Excuse me. It's this is not a number. So, if you calculate, so let me redo it. So the success probability is the probability of cancellation, which happens twice, right? And the failure probability, the probability that the cancellation does not happen is 90%. That happened 8 times because out of 10 reservations, 2 are canceled, but the other 8 are not. So you get these numbers, and finally, you multiply them. So this is the combination, and this is success probability, and this is failure probability. And finally, you get this number. But an easier formula is using like formula, binomial distribution formula. You can simply type binomial in formula tab. So go to formulas tab and insert function and search for binomial. Then you will see many formulas, but especially we are looking at the first one, binom.dist, binomial distribution. It returns the individual term binomial distribution probability, right? But it has 1, 2, 3 arguments. Right. Like no, 1, 2, 3, 4 arguments. Let's click this. So you have to enter 4 arguments. First one is the number you select. Here, we are looking at 2 cancellations out of 10, right? So the number of trials is 10, but number of success is 2, right? And finally, the third entry is the probability of success, which is probability of cancellation 10%. And finally, this part is interesting, cumulative. You have to choose either true or false. So if you use true, then it will return cumulative probability, but we are not looking at the cumulative probability. We are calculating false probability, non-cumulative. Then you get this number. This is probability that number of success equals 2, right? So this is an easier way. In the end, I'm following the same formula as I separately calculate each term, but you can do it in one step using binom.dist formula, right? Similar way, I will like say binom.dist. I will calculate probability of y equals to 1, and also let me calculate the probability that no cancellation happens. All right, this is probability y equals to 0. Okay, so look at the formula. The parameters are the same: 10 trials, 10% false. These three entries are the same, but I only changed the first entry. Here it is 0, and it is 1, and it is 2, right? If you look at here, they are just changing this much. Then what I'm going to do is, now let's think about probability y is smaller than or equal to 2. Right? The probability y is smaller than or equal to 2 is basically sum of these three probabilities. Right? Cancellation is, there are 2 or fewer cancellations. That means 0 or 1 or 2 cancellations. A simpler way, technically you have to calculate 3 probabilities and accumulate them, or add them, sum them. But this is where you can use the cumulative probability option. I'm coming here again. So let's think about 2 cancellations out of 10 reservations. Probability is 0.1. And if you enter true in the fourth entry, cumulative option, if you enter true here, then you will get this number, right? So by entering true, you are calculating probability from the smallest up to this point, up to 2, right? That's how you utilize the cumulative probability, okay? And let's move to another option. Let's think about this case. So in the overbooking example from the slides, we have 22 reservations, but only 20 seats. Cancellation probability is 10. In this case, we are curious about the probability greater than 20, right? That means we have 22 reservations, but only the capacity is only 20. So if there are 21 people coming to coming to the airport, then you are in trouble. Then you may calculate probability like this. Right? So this calculate those probabilities like binomial distribution. Number of success is 21 out of 22, and so you may calculate this, and which is extremely small probability, right? And so these are the very small probability. That means, so 2 alphabet E minus 20 is, it is 0.0000 and with 20 zeros, and here are 22 zeros. If you see this is say as a number, you are going to get 20 zeros. So there are 20 zeros multiplied by some number. Anyhow, it is an extremely small probability. And then probability y is greater than 20 is sum of these two. Okay, still small probability, but a better way to calculate this is probability y greater than 20 is 1 minus probability y is smaller than or equal to 20, right? This is the reason why I'm transforming the probability to this side is because probability y is smaller than or equal to 20 can be calculated by the cumulative probability, like say binomial distribution, say 20 out of 22 with probability 0.1 and put true here, then you will get a probability which is very close to 1, of course. So you will get, how many zeros do I have? Wow. Did I do anything wrong? So the probability is nearly too many. Then if you take 1 minus this probability, it will be, oh, something is wrong. What is wrong? I don't think there is anything wrong. So this is the probability, like you can calculate the same probability using cumulative probability function. Why is it different? Okay, so anyhow, the probability is so extreme, so it's hard to see how correct this is, but I think the Excel cannot handle this small probability. So anyhow, I wanted to show you how to use the formula in Excel. So in doing your quizzes, you can also use Excel because that's why we are learning Excel. Okay, so I hope it's helpful and see you later. Bye.